Hi guys, it's Mr. Brian here. In this video, I'm partnering with EduKaji to guide you on the SPM 2022 physics paper. We will be discussing paper 2 on essay and structure. Without further ado, we will get right started with question 1. So this is your 2.5 hours paper. Question number 1. Diagram shows the result of an experiment to determine the relationship between buoyant force and depth of rod immersed in water. Okay, so the idea is simple. You got, let's say, a beaker. The deeper you immerse the rod, the greater the volume of water displaced. Therefore, you will have more buoyant force. Okay, so the idea is quite simple. State the type of physical quantity for buoyant force. Now, whenever they say type only got 4 possible answers. Either your answer is base or derived, either one, or your answer could be scalar or vector. Okay, usually you can pick one from base or derived, and then you can pick one from scalar and vector. Yeah, buoyant force is definitely a derived. Yeah, base, is the most basic ones. Like base means like length, time, or the some mass. You can also say it is a vector quantity because force has direction. And normally a buoyant force is pointing upwards. Yeah, so either one. You just write one only, okay, in exam. Based on your diagram, pick the manipulated variable in this experiment. Manipulated is the depth of rod immerse, which is your x-axis, right? Usually the y-axis we will call it the responding variable. So you change the depth of how much you immerse, and then you get the buoyant force as a result, which is the y value, the responding variable. Okay, determine the value of FB when the depth is 0.07 meters. Show how you get the value. Okay, depth 0.07. When they say show, it means you just need to take out your ruler and draw it out for them. Look for 0.07 and just dot it out. Okay, right in the middle between 0.06, 0.08, that is 0.07. And then again, dot it out. Okay, you do this, you are going to get 1 mark for drawing the line. Okay, and your answer, okay, next thing is you need to think how to read this. Okay, a lot of people are sometimes stuck with it. If you find it confusing, one very easy way is you just take this number, and because from 0 to 0.05, there are 10 small boxes. So you just divide this by 10. You just move one decimal place back. You will know every box is actually 0.005. One box is 0.005. Yeah, for those of you who are confused, you don't really know how. Then you just take this one, this 0.15, and you plus 1, 2, 3, 4, 5 small box. 0.15 plus 5 small box. Every small box is this 0.005. Confirm your answer is correct. Okay? Or some of you will say, teacher, I just take the value in between these two. Can I just find the midpoint? Up to you how you want to do it. Okay? Or some of you will say, teacher, I think every 2 box is 0.01. So here 0.16, 0.17. This is 0.175. Up to you. You will get 0.175, which is the value in the middle here. Okay? That's all. You draw the dotted line, you get 1 mark. That's how you show on the graph. And then you write down the answer 0.175 Newton. Okay, that will do. Okay, the unit already given, so you don't need to write again. Question 2. The diagram shows a photocell circuit. The semi-cylinder cathode is coated with a light-sensitive metal. When the cathode is illuminated with a beam of light, electrons are emitted from the metal surface, and the milli-ammeter pointer deflects. Name the phenomenon that causes electrons to emit from the surface of light-sensitive metal. They keep saying light-sensitive metal. You shine some light and electrons get emitted. That is photoelectric effect. If you shine a light and electrons emit, that is called photoelectric effect, where you use light to create electricity. Okay, photoelectric. If you're using heat to heat a cathode and then the electrons is emitted, that one is called thermionic emission, using thermal energy, thermionic emission. Part B, for 2 marks, explain how the milliammeter pointer deflects. Okay, the reason why it will deflect, please understand, is because the circuit is complete. So the cool part about this, right, is even though inside here, there's no wire connecting the two ends. Yeah, there's no wire connecting the two ends. Normally, if you want electricity to conduct, you need a wire to connect all of them together, right? However, we found out that if the electrons, if there are enough electrons moving over, well, then this orange color circuit can now be completed. So your focus is to explain the fact that the electrons complete this circuit. Okay, so first point, maybe I can say something like the electrons are attracted to the anode. And when the electrons move to the anode, it completes the circuit. Yeah. When electrons moves to the anode, the circuit is complete. Current flows. That's how milliammeter pointer deflects. If you want to add the definition of current, you want to say there's a rate of flow of charge, can also. Okay, so the whole idea is you just say the electrons will go over. When it finally goes over, the circuit is complete and current would flow. Okay, I will combine these two as 1 point also can. Yeah, so you get 1 mark here, and then the fact that the circuit is complete or the current flow, or you can write both is 1 mark. Can Part C, the threshold frequency of light sensitive metal in the photocell is that calculate the work function. Don't worry, because formulas are given. If questions say, can you go and find the work function? That sounds like W. Threshold frequency, do you know that is FO? Planck's constant are given. Okay, so SPM will give all this 6.63 times 10 power negative 34. This is your work function, sorry, your threshold frequency. Okay, 6.63 times 10 power negative 34. Multiplied with this. Everything SI unit, don't need to worry. Hertz is in SI unit. You're going to get the answer for work function in joules. Work function is the minimum energy to bring the electrons out from the metal surface. Threshold frequency is the minimum frequency of light you need to shine so that electrons will come out. If you shine a too low frequency, the electrons don't want to come out. You need to shine a high enough frequency. How high? Higher than the threshold, higher than the FO. Then electrons will come out. Okay, work function is the minimum energy to bring the electrons out, to emit the electrons. Okay, so we multiply together, you're going to get let's check. Oh, did I 3.4476 times 10 power negative 19. This is what my calculator gave me exactly. You want to round off also can. 3.448 times 10 power negative 19. Also okay. Also okay. Right. Joules is fine, but some people will say, teacher, what if in exam I forget the unit? Then how? Then you just copy, like for example, this is joule second, right? And then this is hertz, right? So what if I wrote the unit is joules second hertz? Will they mark correct or not? Yes, they will still mark correct. Okay, in school exam, maybe they won't, but in SPM, they will, because it's not wrong. It's just that maybe some of you don't know that hertz is actually the same thing as per second. So what you're writing here is joule second and then per second. That's why they cancel out. That's why it is just joules. Yeah, work function is the energy. Okay, question number 3. Diagram 3 shows a graph of activity against time for radioisotope decay of iodine 131 with a certain half-life. What is meant by half-life? Okay, this definition is pretty popular. I think 2023 or 2024 also got asked about this, the definition of a half-life, which is the time taken to decay to half of the number. Time taken by a sample of radioactive nuclei to decay to half of its initial number, or original also can. Okay. Other ways that you can also say that they will also accept is that time taken for the number, instead of sample, a sample meaning like, let's say I have a bowl of radioactive nuclei. When half of it decay, the time taken for that is called half-life. So you don't want to say sample, you can also say the number of radioactive nuclei. Can But remember, it is all about the nuclei. It is not about the atoms. That's why this is called nuclear physics. Okay, Ken? This is the textbook definition. Ken? Okay. You forget number, you can also say mass, also accepted one. To cut down to half of the mass also can. Part B, based on diagram 3, determine the value of half-life. Show on the graph. Again, this year they quite like to ask about to show on the graph the half-life. So what you do is you go and look for half of 1,000. When the activity is 1,000, that's the initial activity. Now, half of 1,000 is 500. You have to be careful. The graph is not drawn to scale. The graph is not drawn to scale. You take your ruler, you put 500. Okay, and then you draw down. You should get, I think, 4 minutes. I think it's exactly 4 minutes. Sorry, not 4 minutes. Sorry, I saw wrongly. Wait, let me do this again. Okay. They split, sorry this scanned version is not great, but it looks like 4 boxes. Okay, so how to do this? Here got 5 boxes. Okay, you take 4 and then you divide by 5 boxes. You will get 0.8 for every box. If every one box is 0.8, you just multiply 0.8, 0.8, 0.8, 0.8, 4 boxes. That would be 3.2. Okay, so if you find a weird number, don't worry. You just take how many box and then you divide. Okay, I know guys, it looks like my line a bit sengit, but that is because when I scan this, maybe it is a bit sengit to one side, but it is coming from the 4th box here. Okay, it is 4 boxes. I will get 3.2. Okay, 3.2. Did they put the units? They didn't, so we put ourselves minutes. Okay, 2 marks. Draw a dotted line, get 3.2, done. Determine the activity after 4 half-lives. Okay, so originally you have the activity as 1000. After 4 half-life, there's 2 methods. One easy method is you go and take, like you go and draw like this, 1000. You draw one arrow. Every arrow represents 1 half-life. You take 1000 and you divide by 2, you cut into half, you're going to get 500. So 1 half-life later, you get 500. This is 1 half-life later. Another half-life later, you divide by 2 again. You get 250. Another half-life later, you divide by 2 again. You get 125. So far, how many half-life? You count the arrow. 1 half-life, 2 half-life, 3 half-life. Every half-life is, by the way, 3.2 minutes. Then you have to divide by 2 one more time. 62.5. Okay, so the answer is after 4 half-lives, you have 62.5 as the activity. Okay, activity actually has a unit of counts per minute. Just copy from the graph. Like 1 mark for your arrow. You don't need to even write this. Also, it's fine. Whether you write or not, it's fine. And then 1 mark. Okay, so this is the easier way. So just draw arrow. The other way that you want to do, that you can also do, is to go and use the formula under nuclear physics. This one right here. Okay, where the number is equals to bracket 1 over 2 to the power of n, and then NO. NO is the original number. So if you do like this, okay, you want to find the number at the end. Sometimes we will write like this also. In your textbook also, they'll write like this. A represents activity. N represents number. It doesn't matter. The formula is exactly the same. Okay, so I want to find the number after 4 half-life. So I will put 4 here. Small letter n is how many half-life? And then the original number or the original activity is 1000. Okay, activity and number, they behave the same way. You type in your calculator. You're going to get same answer, 62.5 pounds per minute. Okay, you get 1 mark, 1 mark. Also can, either one. To me, I think this is easier. You just draw arrow only. If it's just 4, you just arrow 4 times. Done. This is the answer. Okay, can. So some people normally they will say, teacher, I understand what is the meaning of number, but activity I don't really understand. It just means that imagine you have a sample here, okay, of radioactive nuclei. And at first, there are 1000. I counted the activity, got 1000 of alpha particles shooting out, let's say. At first got 1000. But then after 3.2 minutes later, after a half-life later, I found out that when I go and count the number of alpha particles, this time there's only 500 left. Then another half-life later, I go and count the alpha particles. I count how active is it. Because if it's very active, very radioactive, it will keep emitting the radioactive particles. It can be alpha, beta, gamma. Okay. And I go and count. I go and counted, it was 250. And then after half-life, I go and count. You get the idea. So activity is literally you go and count how many alpha it come out or how many beta it come out. The side is how many counts per minute. You literally go and count the number. Yeah. Okay. Part D. Why does the radioisotope decay continues to occur? Why would something decay? Because it is unstable, or because it wants to be stable, right? You can say because the nuclei are unstable. Or you can say because the nuclei can become more stable if they decay. You can say to become more stable. Nobody likes to be in a state where it's always unstable. We always would try to find a way to be stable. And in this case, we by decaying, meaning we emit some alpha or beta or gamma. And when we emit all these things, we will slowly become more stable. Okay. Question 4. The diagram shows a weather forecast satellite orbiting the Earth at a height of 850 km. The satellite is a non-geostationary satellite. Okay, state one characteristics of a non-geostationary satellite. There are many things that you can say. If you memorize geostationary, you just have to vomit out something that is the opposite of non-geostationary. For example, geostationary has to be 24 hours orbital period. This one, it can be longer or shorter than 24 hours. That's one of the easiest, right? Or geostationary is always above same geographical location. This one, I would say always above different geographical location. Okay, another good one is orbital period is longer or shorter than 24 hours. As long as it's not 24 hours. Can be longer, can be shorter. Okay. And the orbit can be higher or lower than Earth geostationary Earth orbit. It is higher or lower than geostationary Earth orbit. Okay, and still got many other answers. Like you can also say the orbital period is different from the orbital or the rotational period of the Earth, because normally Earth would rotate 24 hours and geostationary normally they will follow. But this one they won't follow. So you can just say the orbital period of satellite is different from rotational period of Earth. Also can. Okay. Or you can also say the direction of orbit doesn't have to be the same as the direction of rotation of Earth. Direction of orbit doesn't have to be the same as direction of rotation. Guys, please make sure you know the difference between rotate and orbit. Don't mix up the two words. We are quite strict about it. Huh? Rotate is for the Earth right now. Orbit is for the satellite. Satellite will orbit. Earth will rotate. Okay, and got many other answers now. So I feel this few are the better ones. Any one will do. Okay, then part D, they gave mass of Earth, they gave radius of Earth, G value, and then they say using these two formulas, find the linear speed of satellite and also the orbital period of satellite. 5 marks. Okay, now they just ask us to sub in only. So linear speed, memang we will use this normally of the satellite. It's just that okay, we sub in the G first. Huh? It's just the R lah that will be a bit troublesome later. M value, mass of Earth, is 5.97 times 10 to the power of 24. Okay, small letter r is the total distance from the center of the Earth to the satellite, from here until here. That is small letter r, the whole distance. Right now, radius of Earth is only here. We call it big letter r. While the height above the surface of the Earth, we call it h. In short, total distance of small letter r is equals to big letter R plus h. This is something you all need to know. Some questions, they will straight away tell you the radius of the orbit. The radius of this circle, the radius of the orbit is what value? That one is small letter r already. You don't need to plus. This question, you need to plus yourself. Okay, it depends on the question. Don't memorize. Not every time need to plus. Sometimes need, sometimes don't need. Read what they give you. If they give you the whole thing already, then don't need to plus. If they never give, then you plus separately. Okay, so you want to add separately, can. You want to do the whole thing in here, also can. Let's say I do radius of Earth. So, and there's one thing that I don't quite like in this question, that is, in the textbook, normally radius of Earth supposed to be big letter R. And I think when they write small letter r like this, it can confuse some students who are not very strong with the symbols, because you might be thinking, oh, do we just sub this in? No, we do not. Okay, no, we do not. You have to go and add. You have to go and add radius of Earth with the height of 850 km. But be careful, km is not the same as meters. Km is times 10 to the power of 3, or you want to write 3 more zeros. 850,000 also can. Okay, kilo means times 1,000. So you want to write 850 times 10 power 3 or 850,000, up to you. Okay, the rest is calculator work. Let's see, I'm going to type everything one shot, see whether you can or not. I get 7426.454 if I round off. Okay, 454 meter per second. Everything SI unit. If you want to write it in standard form also can. 7.426 times 10 to the power of 3. Minimum 3 decimal places now. Okay. All right. The period of the satellite. Period, the formula is this really complicated looking thing. Okay, maybe I do at the top here first so that I can refer to the values. And then later I will copy down there. So my formula looks like this, looking quite complicated. Again, the R you have to go and add. Yeah. So by the way, sometimes some people will go and write the formula as this. Because they know you need to plus, they'll write like this. Okay, same thing here. This one, you have to do radius of Earth plus h. And then you somehow need to go and cube r cube, and then down there is g times mass of Earth m. Okay, when you get this answer, you are not even done because it is just getting the value of t squared. You still have to go and square root your answer. So guys, when you type this, the pi, you can just use your calculator value. Don't need 3.142 like in Admaths. Just use the pi button in your calculator will do. Don't forget to square 4 pi squared times 6.37, 10 power 6 plus 850, 10 power 3, close bracket. Don't forget to cube. And the bottom, we have okay. I got this really long thing. I don't really care about this value. This one, no marks on. But just to show you, if you want to double check, this is what I got. Okay, I'm just going to straight away here, right? In my calculator, I type square root of my answer button. That is what I care about. Square root answer, I get 6108.514. Yeah. And the answer will be in seconds because I've been dealing with the SI unit. Okay, can? Done. There you go. This is for the period. Okay. Then then part C, formula already given. And if they don't give it in the question, they will normally give in the formula sheet. So you don't need to worry. They do not expect you to go and memorize. Okay. Part C, state 3 effects on a satellite when the linear speed of a satellite decreases from the proper linear speed of a satellite. Okay. Also, many students don't really have a good concept on this. I realize they are thinking like, teacher, what do you mean by it decreased from the proper linear speed? Now, the next question will be, do you know that if I want my satellite to be exactly at 850 km height, it must be at this speed. If you don't travel at this speed, the consequence is Earth's gravity is going to pull you down. right? The reason why a satellite can keep on going round and round in circle is because it is traveling fast enough. Let's say here we found out the speed is that 7,000 something, 7.42426 times 10 power 3, which means 7.426 km per second. Okay, that's what we calculated, 7,426 meter per second, which is same as 7.426 km. And you think about that, 7 km every second. 1 second, you blink your eye, already travel 7 km. That is how fast the satellite needs to move. Because if it doesn't move this fast, then Earth's gravity is going to pull the satellite back if you move too slow. So the formula of V equals to square root gm over r is teaching us that if you want to be at a certain distance, you must be at a certain speed. Now, another question would be, what if I have another satellite that is double of the mass? This one is just 1 times of the mass. This one double of the mass. What speed do I need to be? I will still need to be at the same speed. Does it matter the mass of the satellite? No, it can be double the mass, triple the mass. It doesn't matter. According to the formula, if you want to be at a certain distance, you must be at a certain speed. I don't care how heavy you are. You want to be here on this orbit? No problem. You want to be at a height of 850 km? No problem. Make sure you travel at this speed. If you are too slow, Earth will pull you back. Now, one of the few things that we will say in our answer is that when Earth will pull us back, you will slowly enter the atmosphere. Okay, when it's very high up, there's very little air. You're moving in space. There's very little air friction. But the moment you enter the atmosphere, the friction, because you're moving so fast, and then the friction with the air is going to produce a lot of heat. And normally, a satellite that fall down is oftentimes looking like a fireball. The whole thing is like heated up, and the whole thing has a lot of heat. Yeah. So those are some of the things that we will say lah. First of all, the easiest one is you can say, what will happen? You say the satellite will fall to a lower orbit. Fall to a lower orbit, or you can say the orbital radius decreases. It will start to fall down because you are too slow. The formula say if you want to be at that height, you must be at that speed. But now you are lower than that speed that you need to be. Earth will start to pull you down. You would fall very fast. So maybe you can say, as you fall very fast and you enter the Earth atmosphere, air friction increases. Air resistance also can. And then satellite heats up. Or you want to say temperature increase. Can. Satellite burns. Explodes. They accept more. Yeah. Satellite hits the Earth. Satellite becomes very hot. All can. Yeah. So you just write any correct answers already correct. But other than that, got some extra points that you can also say that they also accept. I feel this one is a bit out of the box, thinking out of the box a little bit. As it falls down, it is falling with quite a high velocity. Okay, what happened to the satellite? You say the satellite falls with high velocity because it's moving quite fast. Even if it doesn't follow the exact speed of 7,426 meter per second, let's say it's traveling a bit slower, 6,000 something, it's still very fast. 6 km every second, still very fast. Falls with high velocity, falls with acceleration. . also can, and gravitational force on satellite increases. Other than gravitational force, gravitational acceleration on the satellite increases. The closer you are, the stronger the gravity, of course. Got many answers. Yeah. So if you understand the idea, then I think this question is not hard. Okay, we move on to question 5. Okay, diagram 5.1, 5.2 shows the effect of superposition of two coherent waves of two coherent water wave source S1, S2. Okay, the solid line is a crest, the dotted line is a trough. Superposition has two other words that have the same meaning. It means overlapping of waves. It also means interference of wave. They all have the same meaning, these three words: superposition, overlapping, interference. Okay. Part A, what is the meaning of coherent sources? Coherent sources means waves with the same frequency, waves with same frequency and constant phase difference. Okay. Constant phase difference, that means not only their wavelength is the same, but the way they overlap is always very perfect. Like normally it might mean that there's two source, you put them side by side like that. You don't put one too far out like this, because it will cause the phase difference to be quite off. Yeah, we never really learn much about phase difference lah, but in like, let's say if you take A levels and all, or Form 6, then you will study a bit of that phase difference stuff. But at this stage, you just think, okay, wavelength must be the same. It also means that the way they overlap must always be very perfect. You put them side by side, like that kind of thing. Okay. Part B, observe diagram 5.1, 5.2, compare the distance between two coherent sources A. Okay. Diagram 1, smaller A, diagram 2, bigger A. Because it is a structure question, you can say like this: diagram 5.1 smaller than diagram 5.2. Okay, like I said many times, in SPM, you can write the symbol smaller than. In school exam, some teachers, they don't like this. They don't want you to write this. They want you to write is smaller than. Okay, or is shorter than. Now, if you ask me which one do I prefer, I'm okay with both because SPM allows both. But of course, as a teacher, I would prefer you to write in words, because it just looks nicer like you're answering the whole thing in words. But honestly speaking, both are fine. Okay, so if you feel like you want to write words, you just write 3 words, is smaller than. You feel like you're okay with this symbol, go ahead. SPM will accept both. Yeah, just check with your school teacher. If it's school exam, some teachers, they don't accept this. That one, we cannot control. You need to check with your teacher. Okay. Also, some school teachers will ask you to copy this, which is a good habit. Okay, so if your teacher say, please copy this and write here, you do it. Okay, but in SPM, is it needed? Actually, no. Only for structure questions, Tony. The reason why your school teacher will ask you to copy this and paste here is because in essay question, section C, you must copy. Section C must copy. Structure question, up to you. You want to copy, you don't want to copy, also correct. Okay, but 2, the distance between two consecutive antinodal lines, X. This one, the X is bigger. This one, the X is smaller. Diagram 5.1 greater than diagram 5.2. Again, you can just write this as is greater than. Part 3, The distance between two coherent sources to the detector line D. Okay, the D is the same. Oops. The D is the same for both. So you can say equals like this. Okay, you can write like that in SPM. So whatever I write here, you can write in SPM. If you don't want to write is this equal symbol, then you write it as is equals to, or same is the same as also can. Okay, so part C, they ask relate the distance between two coherent source A and the distance between two consecutive nodal lines X. Okay, because they did give you the symbols. So if you write the symbols, it is accepted one. Like for example, you saw that if the A is smaller than the X is bigger, right? So if you write something like that, because the question already wrote the symbol, the greater the A, the smaller the X, let's say. Can they accept? Or you want to write if A increases, X decreases. Also can. You want to say that if you're very confident, you want to say that they are inversely proportional, also correct. But you only write inversely proportional if you are very, very sure. Normally, this kind of question, I don't recommend it. Okay? But if you want to, if you're very confident, you know the relationship is memang inversely proportional, okay, can, go ahead. Okay? If you want to write the full name also can, you can say the greater the distance between two coherent source A, the smaller the distance between two consecutive antinodal lines X. Can also. If you are paranoid, you feel like, teacher, I'm sitting for SPM one time only, I want to write properly everything, go ahead. We will not penalize you. It is even better if you write more. You write the whole thing. It is okay. Okay. Part 2, name the wave phenomenon involved. It is called interference. Okay, interference of waves. Okay, then part D, they asked to calculate, based on diagram 5.3, calculate the distance between two consecutive antinodal line X. Now, you want to use the interference formula, which is given. This one. Okay. Lambda equals to AX over D. Yeah. And question asks you, please go and find the X. First of all, lambda is the wavelength. If you go and count from one trough to the other trough, this is your wavelength, 1.8 cm. Okay, maybe I don't write the cm because everything will be cm, by the way. And then the A value is, so this is your wavelength. The A value is the distance between the two coherent source. The 10 cm is the D value. Just put everything in. So 3 and then multiply by X divided by 10. Okay, then you do your working. This one multiply, you get 18. This one you divide by 3. 18 divided by 3 is 6 cm. Okay, there you go. Or maybe should I write big letter X? It doesn't. They won't penalize for this one. It's supposed to be small letter, by the way. Just that this question they use big letter, so you can follow. Part 2, what happens to the distance between two consecutive antinodal lines if the frequency is increased? Okay, this is actually a good K-bar question. You might be thinking, teacher, in this, according to this formula, there's no frequency here, so I think the answer is unchanged. Now, what happens to X? You might say X unchanged. No, this is wrong. This is the answer that most students wrote, which is wrong. Even though frequency is not in this formula, but when frequency increases, wavelength always decreases. And if you're wondering, hey, why? Because of this formula, V equals to F lambda. right? Not when you can divide the F come down when frequency increase, wavelength always is lower one. Oh, so that tells you that the lambda will decrease. And what happened to the X? X will also decrease. The answer, correct answer is X decreases. If they ask for something extra, they ask why, you tell them X decreases because wavelength decrease. Wavelength will decrease when frequency increases. Okay, that is your answer. If they ask for one more, then you get another mark here. One more mark here. Can? So the whole question is playing with this formula, the relationship of this formula, and can we remind ourselves that I always like to arrange the equation so that X is on the right side. I can multiply the D up, I can divide the A down. And guys, the previous question was comparing how A affects X. When I got greater A, I will have smaller X. Right? They are inversely proportional. Why I make X alone here? Because X is always the responding variable. X is always the responding variable. I can change the wavelength, it will affect the X. It won't kacau the D, the A. I can change the D, it will affect the X also. It won't kacau the wavelength, it won't kacau the A. I can change the A, it will affect the X. It will not affect the lambda, the D. So everything here could be the manipulated variable. But X is the only one that is responding. Okay, question 6. Diagram 6 shows two athletes rowing a kayak P and Q, which are identical. The kayak has the same weight, 300 newtons. Both kayak are floating in the river water. Athlete X and Y are 800 newton and 500 newton respectively. Kayak is this weight. 800, 500 is the weight of the humans. Okay, what is the meaning of weight? Gravitational force acting on an object or on a body. On an object, or you don't want to say, you can say on a body, it's fine. But keyword here is that weight is gravitational force. What is weight? Weight is a type of force that comes from gravity. A force due to gravity, gravitational force. Okay, using force concept, state how the kayak can float on the water surface. It can float because, what is the reason the kayak won't sink? What is the reason the kayak will not fly up? It's because the force pointing up and the force pointing down are the same, are equal. That is the reason why it can float. This kind of question are pretty popular because they are equal. Okay, so you say the buoyant force is equals to the total weight of kayak and athlete. Did I spell athlete correct? A-T-H, there's an extra E. Okay, and the athlete. Okay, why I say the total weight is because the weight comes from kayak plus athlete. That's the total weight. They gave the weight of kayak is 300 and then the weight of athlete is 800 and 500. Yeah, okay. Then part 2, kayak P has displaced a certain volume of river water when floating. Calculate the volume of river water displaced. Okay, now if you go to the formula sheet, usually this formula is not given for buoyant force. We take a look for pressure. You cannot find it. Okay, you cannot find it. But according to Archimedes Principle, Archimedes saying that the buoyant force is equals to always the weight of water displaced, weight of liquid displaced. Weight is mg. And Normally we don't have the mass. So we need to go and change mass to become density times volume. And you sub that in. Okay, so this is just to remind you, this is how we get formula for buoyant force. Buoyant force equals to weight. Weight is mg of water displaced, weight of fluid displaced. Mass is density times volume. That's why buoyant force is rho vg or v rho g. Also can. Buoyant force is rho vg. Okay. Density of water, because this is all mass of water, weight of water displaced is all about the water. Density of water is 1000. Volume of water displaced is V. G value 9.81. Question is, we are missing the buoyant force. Okay. And since you say the buoyant force is equals to the total weight of kayak and athlete, can we say that kayak P, okay, kayak P is the first picture. According to this picture, the weight of kayak is 300 Newton. The weight of athlete X is 800 Newton. So the total weight of the kayak itself and the human is 1100 Newton. If the weight is 1100, the buoyant force is also the same. Okay, can you understand? So weight and buoyant force must be equal. And then if they ask you what concept is this that makes it float, I will tell them that this is forces in equilibrium. The concept is forces in equilibrium. Yeah, so my buoyant force is going to be straight away. You want to write 1100 can, or you want to add 300 plus 800. Okay, weight of the kayak plus weight. The kayak is the boat plus the human. Okay, you get 1100 here. Equals to, you can multiply all this together if you want, you're going to get 9810 times V. Then you divide over V equals to 0.112. Okay, minimum 3 decimal. You want to write more, up to you. That is in meter cube in SI unit. Okay, part C, based on diagram 6, which kayak accommodate a larger load? Or they are asking you only which kayak is holding a bigger load. Which kayak is holding more weight? The first kayak, lor. Because this one is 1100 Newton, while this one is how much? The kayak is 300 Newton. The weight of athlete Y is 500 Newton. So in total, the weight is 800 Newton. So which kayak holding more weight? Kayak P. Okay. Not which kayak can accommodate, no, not which kayak can. Is the kayak is the same. They're just asking which kayak is holding a heavier person. Kayak P. Okay. Which kayak displays more volume of river water? Kayak P. You know, when they ask this question, some people will think, oh, teacher, this one's so easy. Really, they ask something like that. Yes, they are just testing on the students. Do you know what is the meaning of displace more volume? It means who has more volume of the kayak under the water? This green color is the volume of water displaced, the volume of the kayak under the water. While this one displays less. So this green color highlighted part tells you the volume displaced is big here, volume displaced is small here. Volume displaced is the same as the volume underneath the water, immersed in the water, submerged in the water. Okay, which kayak has a greater buoyant force? Also kayak P. Okay, so a bit special. They didn't ask to compare kayak P, kayak Q. They just asked straight up which kayak bigger. The buoyant force. This one 1100. This one the buoyant force is 800 Newton. Buoyant force and weight must be the same, or else it will fly up. If one of the forces are bigger, it will either fly or it will sink. But this one never. Okay, using your answer in question 6C, relate the weight of the load and the volume of water displaced. If you are heavier, you will sink deeper. You will displace more volume of water. The greater, the greater. The greater the weight of the load, the greater the volume of water displaced. Okay, what about weight of load and buoyant force? The greater the weight of the load, the greater the buoyant force. If your load is heavier, then you need more buoyant force. Another way that you can say it is also the weight of the load must always be equals to the buoyant force for it to float, right? So greater weight means greater buoyant force. Huh? You don't want to write greater, you want to write increase, also can. As the weight of the load increases, buoyant force increases. If you don't like the word greater, you can say the higher, the larger, the bigger, all the same. No problem. Okay, that is question number 6. Then in question number 7, okay, light chapter. The diagram shows a ray of path propagates in a glass prism. The refractive index of the glass prism is 1.49. Okay. What is the meaning of refractive index? The answer of this you can actually find in the formula sheet usually. Just take any one. Usually we will take this. Okay, these two. These two are the one that are most commonly accepted. So you write any one of them already correct. So you can say either is the ratio of speed of light in vacuum to the when I say ratio, that means divide. Ratio of speed of light in vacuum to speed of light in a medium. Or ratio of sine of incident angle to sine of refracted angle. Also can. Okay. Either one. But I'm just gonna write one now. I want to usually I'll write this one. Okay. Ratio of speed of light in vacuum to speed of light in a medium. Another one that you can go ahead and say is sine I over sine R. Usually these two are accepted. Calculate the critical angle of the glass prism. They ask you for the C value, and there is a formula that has this. This formula also given. Yeah. The N value you already know is 1.49. So you just sub in 1.49 goes to 1 over sine C. Done. You can multiply the sine C go up, you divide the 1.49 come down, sine C equals to 1 over 1.49, and then type in your calculator, shift sine 1 over 1.49. Done. That's your answer. Okay. You are going to get 42.155 degrees. Okay. Normally they will just do 3 decimal, you just follow 3 decimal. Okay, then part 2, draw the path of light ray after point O. Okay, when it's at point O, this is actually a very common picture. Now, they are just testing you whether do you know that the normal line looks like this. Let me show you. This is the normal line. The normal line is always 90 degree to 90 degree to this boundary, this surface. Okay, and do you also know that the incident angle is actually 45 degrees? It will be the same as this angle. Reason being, because here is also 45, right? You can take a triangle, 180 degrees minus 90 minus 45, you will get 45. And then, because here's a 90, you will also get a 45 here. And because here's a 90, you will also get a 45 here. So if you go and count, these two angles always the same one. You're gonna get 45. And the next question is, do you know that a glass prism is a transparent piece of glass? And normally when we think about a transparent piece of glass, we are thinking that light is going to come out. It's a transparent glass, light will come out. The beauty or the magic about total internal reflection is that it traps the light inside the glass so that the light will just travel this way. And why is it straight up? Because the angle must be the same. You go in 45, it must also come out 45. 45, 45 meaning a 90 degree. Therefore, it is a 90 degree, like this. Okay, so just like that. The answer that I want is this purple color one only. 1 mark. You never draw normal line, everything, all don't need, is fine. But as long as you understand. Now, if you are thinking, teacher, why total internal reflection can occur? Oh, that is because at this point right here, light is trying to travel from denser to less dense. Or maybe I say high to low optical density. It is trying to travel from a glass which is denser to air which is less dense. Number 2, because the incident angle is bigger than the critical angle. The incident angle is 45 degrees. It is bigger than the critical angle that you just found, 42 degrees, 42.155. If you can fulfill these two criteria, then the light will get reflected inside. Internal reflection. It will not come out. It will not have a refraction. It gets stuck inside. This is the reason why a diamond can be so shiny, because light gets stuck inside the diamond. Diamond is transparent also, normally light will come out one. But then it gets stuck inside because inside got a lot of total internal reflection. So when you look at the diamond, a lot of light gets stuck inside, makes it look so shiny. Yeah, okay, so done. 1 mark. Part C. The diagram shows the image of a drop of dew at the tip of leaf taken using a macro lens to focus a close range object. Okay, a macro lens is actually not in your syllabus. Yeah, and then the table shows some characteristics of lens PQR. Okay, the easier one is I would definitely want a big diameter of lens. Okay, a big diameter of lens. And actually, there was a mistake during this in this paper where the focal length actually we want it to be longer. But this is supposed to be in mm. Yeah, it's just that they made a mistake. They put cm eventually. But we're not going to write the number. We're just going to write, okay, I want a longer focal length. Okay, but let's see why. Focal length I want longer. Reason being, if I have a long focal length, I can produce a clearer or a sharper image. To produce clearer can, sharper also can. Not a bigger image. Bigger not accepted. Okay, why longer focal length can make it sharper, clearer, but not bigger? Because for a macro lens, it is a bit special. Let me show you a picture. This is a picture of a macro lens, let's say. Macro lens, the job is to take picture of very close object. Like, for example, this water droplet, this drop of dew. Or, for example, we want to take the picture of this dragonfly. The goal of macro lens is to take picture with a lot of very fine details. It can help you to capture the picture with a lot of the fine details. You can, if you are taking a picture of an ants or a butterfly or a dragonfly, you'll be able to see a lot of the clear details on the wings and everything. It will be very, very sharp. Is to take picture close like this. So if, also another thing that you need to know, your object to your lens, you must always make sure that your camera is near your macro lens is exactly at the focal length to the object. So let's say the lens is like this. You must make sure that the lens and whatever you want to measure must be equals to the focal length. The object must be placed at the focal length, usually. That's why we normally want something that is longer, let's say 90 mm. Because if it's too short, then you have to go very, very close, very difficult to take the picture. So long focal length just makes it easier to take the picture. If you go very close to this dragonfly, the dragonfly will definitely fly away, right? So usually we want a suitable distance. Remember, the goal of this is what? Just to take picture with very, very clear details. Macro lens normally is not trying to zoom in, not trying to magnify the object. Macro lens is just trying to take picture with sharp details, with very fine and sharp details. Normally, not to zoom in. Okay, so this is a KBAT question lah. So unfortunately, when they ask this, many students can't do because it's a bit unfair if you ask me, in my opinion, because macro lens is not really in the textbook. The idea here is so that it's easier for you to take the picture. When you take it, it'll be clearer, it'll be sharper. Okay, then diameter of lens, I want it to be big. Okay, you follow the table. If the table write big, you write big. You don't go and write bigger. If the table write big, you write big. Don't write bigger. If the table give you value and then you go and write longer, okay, that one is fine. Okay, reason for a big diameter is to produce, the best word right now is brighter. If you have a big lens, more light can enter the lens. It doesn't make the lens bigger or what. Sorry, it doesn't make the image bigger or what. It will just make the image become brighter because big lens means a lot of light can go in. That is the best word to talk about. Or you can say more light can enter the lens. And so P is the best choice. P is the most suitable lens. Yeah. Questions like this don't have to be too worried. If it's so KBAT like that, you just do. If it's KBAT for you, it is KBAT for everyone else as well. Yeah. So this is the question. This is not the question that will decide whether you get a good grade or a bad grade. This is not one of those because everyone will be doing not super great at this question. Maybe like they cannot get the reason for this one correct, for example. Okay. But all the other topics so far that we discussed are those questions you need to be good at it, the concept. Yeah. Okay, question 8. Diagram shows a rectification circuit. The cathode ray oscilloscope, CRO, displays the tracing of a current flow through the resistor R. Okay, we got one diode and one capacitor. That's why you get a half wave. They ask the type of rectification, half wave rectification. Originally, the wave looked like this. Up and down, up and down. Now, you only have half of the wave rectified. The other half went missing already. Don't have. Okay. Then part B, the switch in the circuit is turned on. Explain how the capacitor can change the tracing of the current. The job of the capacitor, I always tell my students, is like a power bank like that. Capacitor is like power bank like that. If the moment I turn on the switch of the capacitor, did they ask to draw? Oh, they didn't. The moment I connect the switch of the capacitor, then my output voltage will start to look like this. Okay, this blue color graph. The job of a capacitor is to make sure that my current will never fall down to zero anymore. It will smooth out the current. It will smooth out the current by being something like a power bank. When current flows one direction, it will charge the power bank, the capacitor, and then it will flow to the R as well. But when current flow the opposite direction, because AC means current will keep flowing this way and this way, both direction, alternate the direction. Yeah, it will charge it and it will go to here. When current flow the opposite way, by the way, when it tries to flow the opposite way, the diode won't allow it to flow. So what happens now? It cannot go to the R also. So no current. That's why the graph is flat. This is when the capacitor will come and save the day. Remember, the capacitor is like power bank. Just now you already charged the capacitor. Now the capacitor will go and charge the R. Will go and go to the resistor. The R can be anything, can be a bulb, can be your handphone here, whatever. Okay, so roughly that is the idea. But in short, we like to say this. When voltage go up, capacitor will charge. When voltage go down, capacitor will discharge. You get 2 marks. When potential difference increases, capacitor charges. Or you can also say, it's like a power bank, right? So you can also say energy is stored in the capacitor. Okay. So 1 mark already. Another one is when potential difference decrease. When I notice that the potential difference start to decrease, the graph is falling down, I need to faster come and save the day. The capacitor will now discharge. Oh, by the way, they spelled capacitor wrong. You can follow the spelling, but it's spelled with the letter C actually. Okay. Or you can also say energy is released to the circuit. So I charge myself and then I give energy. I charge and then I give energy. Charge and discharge, charge and discharge. Okay. And then 1 more mark, you can also say eventually it will smooth the output. Output voltage, output current also can both accepted. It will smooth both. Normally, we prefer you to say it will smooth the output current according to the textbook. Okay, but if you go and say smooth the output voltage, also accepted. Cannot. So any 2 points, you get full mark. Okay, can. But see, the diagram shows an electronic circuit with an adapter unit of an alternating current. Suggests how this adapter unit is used to charge a computer and can maintain uniform current based on the following aspects. So, first of all, we have a transformer. Usually, your charging adapter for your laptop or your charging adapter for your phone, that thing, that the 3-pin plug thing, the adapter. Inside the adapter, usually there is a transformer. Because the voltage going into your house is 240 volts and you don't need so high voltage to go to your handphone, go to your laptop. So you need to step down the transformer, which is an AC, by the way. And here you're also going to get AC. Then in this box P, we need to use some diodes and some capacitor. Then only it will go to your computer so that the graph going into your computer will be pretty smooth. That's the job of the capacitor. But please know, originally the graph is a pure AC like so. At box P, the graph will start to become, we want it to become like this. The moment you have your capacitor, it will smooth out the current. It will look something like this. it will be pretty flat. It will not go up and then, it will not go up and then go down, up and then zero, up and then go to zero. It will never touch zero. It will be pretty smooth going into your computer. That's why the adapter normally quite expensive. Yeah. Number of diodes used in box P. It must be 4. Just now, one diode give you half wave rectification. The wave only half. Do you know you can only do 1 or 4 diodes? 1 is half wave rectification. 4 diodes is full wave rectification. You cannot say I want a higher number or lower number. Cannot. You want to say to produce full wave rectification. Only 4 can give you full wave rectification. Not 2, not 3, only 4. Okay, that you can refer to your textbook how it works, but it's either 1 or 4. Full wave, half wave and full wave. This is full wave rectification. The magnitude of capacitance of capacitor. Many students say they don't know what is the meaning of this, but you can make a guess lah. If I mention capacitor, of course the magnitude higher better, and you tell them the job of the capacitor. Capacitance is how smooth it will be, okay? So that you get a smoother current. You get a smoother output voltage, also can. Or you can say it can store more energy because the job of a capacitor is to store more energy. It can store more charge, also can, right? And then in part D, they ask, the transformer in adapter unit of alternating current converts 240 volts to 12 volts. Okay, calculate the ratio of primary to secondary coil. Calculate the ratio of primary to secondary. The ratio of the number of turns of coil is related to the voltage primary to the voltage in secondary. It must be here P and P, down here S and S, for example. Okay, and this is your primary, this is your voltage in primary, this is your voltage in the secondary. Right? You want to follow the formula sheet also can. This is under electromagnetism transformers. A lot. Okay, this one. Okay, they write voltage secondary to voltage primary equals to number secondary to number primary. Anyways, it is SS on top, PP at the bottom. You can also terbalikkan. You can also flip. Doesn't matter. Okay. When questions say ratio, you always go and find the fraction. At maths also the same. I ask you for ratio, you just find out the fraction. Okay. Answer is 240 volts over 12 volts. Calculator will tell you it is 20. 20 is the same as 20 over 1, which means 20 dot dot 1. Done. Okay, that is the answer in ratio. Okay, there you go. I think this is a very good question, in my opinion. A very good one. We continue with essay. Okay, section B, you can just choose anyone. Yeah. Usually they will still mark both lah. Okay. The diagram shows a bar magnet move closer to a solenoid. The deflection of galvanometer can be explained based on the concept of electromagnetic induction. What is meant by electromagnetic induction? Electromagnetic induction is to produce an induced e.m.f. because there is relative motion between the magnet and the solenoid. There's relative motion between magnet and the current and the conductor. My bad, I said relative motion between magnetic field, the magnet, and also the conductor, relative motion. If you move in out like that, you're going to cut magnetic flux. That is how you create e.m.f. Or you can say because the piece of solenoid, this is solenoid, and then you move magnet in out like that. The solenoid is in a changing magnetic field. Also okay. Quite long this one. Production of induced e.m.f. in a conductor due to the relative motion between the conductor meaning the wire, and the magnetic field. There's an or behind in the textbook, or due to the conductor being in a changing magnetic field. Okay, so this one is pretty long. Okay, based on diagram 9.1 state the polarity at x and y. The way I teach my students is I tell them this is Lenz's law. And whenever you push your magnet in, out like this, you're going to create a north and south at the solenoid. Solenoid can create north and south. Now, when north magnet is going into the solenoid, remember, the solenoid will always find a way to oppose whatever it is trying to do. So I tell my students this is a toxic love and hate relationship. When magnet go closer to the solenoid, this is the solenoid, this is the magnet. When the magnet go closer, the solenoid will never say, come closer. It will never say that. It is very toxic. It's a love and hate relationship. So when magnet go closer, solenoid will say, please go away. Magnet go closer, solenoid will say, please go away. I want to repel you away. And how do I repel? I make myself north here so that I will repel you away. And if one side is north, opposite side will be south. That is the poles. The polarity is the poles, north and south of the solenoid. Done. Okay. Now, what if the magnet is going away from the solenoid? Remember, it is very toxic, love and hate relationship. When magnet go away, solenoid will never say, please go, I let you go away. Magnet want to run away, solenoid will try to pull it back. It will try to attract it. Then you think how to attract. If it's north, I can attract it by making myself south. Okay, so you want to pull the guy, you want to pull the magnet in, that means you try to attract it. Attract meaning north and south is north and south will attract. If you want to try to repel it, then you make yourself the same pole, north and north. Or if it's south, then south and south. Okay, so this is the idea. So the polarity at x and y, you just have to say x is north, you get 1 mark. Y is south, another mark. Determine the direction of current that flows through the galvanometer and state the deflection of galvanometer. Okay, this one you have to use your right hand grip rule. Don't look at the magnet anymore. Focus on your solenoid. Your thumb is always pointing to, let's say this is the solenoid. Your thumb is always pointing right hand. Your thumb is always pointing to north, and the opposite side of your hand here is south. This is the solenoid. Thumb is north, opposite end is south. So you follow the picture of your solenoid right now. By the way, don't follow the video because I heard my students normally say sometimes the video is like flip and it looks confusing. But my thumb basically will be pointing to the left. And then the current is going to coil and go behind. If very difficult, you can grab a pen and imagine the current will go up and then coil to the back. Go up and coil to the back. Right hand grip rule. Coil and go to the back. Your thumb is north, this side is south, which is why the current is going to flow this way. If they ask you to draw, you can draw like this. You follow along the wire, it's going to go down like this. And the galvanometer will always point the needle to where the current is pointing from. If current coming from the left side, galvanometer will point to the left. Okay, now the question also asks, determine the direction of current that flows through the galvanometer. Many people also got stuck here. They think flows through the galvanometer, guys, means It is flowing through from A to B, you know. But some people will say, teacher, I thought it's flowing from B to A because I thought it is B flow to A like this. No, this is not what we want. I want you to figure out the current through the galvanometer, inside of the galvanometer. It is A go to B. Okay, and the needle will be pointing to the left. Current flow through galvanometer is A to B, and the deflection of galvanometer, maybe I say galvanometer deflects to the left. Okay, to the left. Or you can say towards A also can. To the left or towards A also can. Okay, so we are looking at the orange color one. Is flowing inside the galvanometer A to B, and it is pointing to the left. Okay, part 3. Explain your answer in part B2. Why you say the current will flow from A to B? Why you say the galvanometer will deflect to A? Don't say because of right hand grip rule and all. That one is just a method of how we figure it out. But the reason is because of Lenz's law. You write this, you will already get 1 mark. Lenz's law says that when you move your magnet in, out like this, I'm always going to produce a current that tries to oppose whatever your magnet is trying to do. Will try to oppose the magnetic field that caused it. It sounds like a very confusing sentence, Lenz's law, actually. But what it's trying to say is, I will try to oppose the north that your magnet is coming closer to. I will try to oppose this north because the north is getting closer and closer. So you say Lenz's law can, you say because the solenoid is trying to oppose north, solenoid opposes north of magnet, or it tries to repel it. You can also say, because Lenz's law says when you move magnet in, out like this, you're going to induce some current. You're going to induce e.m.f. Can. Or you can go and say, because there is cutting of magnetic flux. That's why I got current. That's why current will flow. They're asking you why got current flow. Because got cutting of magnetic flux. Or because got changing magnetic field. Yeah, any one of the answers. Why is there a current? Because solenoid will try to oppose the north. Yeah. Okay. Based on your concept of electromagnetic induction, explain how induced current can be produced in a solenoid. Okay. A good question. I'm going to straight up tell you, there are a few keywords that you must say. First of all, there must be a relative motion, or there must be changing magnetic field. There's relative motion between conductor, or maybe I straight up say between solenoid and magnetic field. You can say conductor also can. Okay. Another one that you can say is there is changing magnetic field. Because when you move your magnet in, out like that, for the solenoid, it feels like the magnetic field is sometimes stronger, weaker, because you go closer, further. And also the direction keeps changing, the magnitude keeps changing. Because there's changing magnetic field, then there's going to be cutting of magnetic flux. If you say cutting of magnetic field, also is fine. Usually we are not very particular about it, but the keyword here is the word cutting. Flux means the magnetic lines. Field means the magnetic area. Flux is the lines, field is the area usually. And then because there's cutting of flux, according to Faraday's law, e.m.f is induced in solenoid. And then because you obey Ohm's, sorry, not Ohm's law, Lenz's law. Yeah, current is induced, or current induced. According to Lenz's law, current induced will always oppose the change of magnetic flux that cause it. It sounds like a very confusing sentence, but according to Lenz's law is trying to say that when you push your magnet in, I will try to oppose. When you pull your magnet out, I will also try to do the opposite always. It is a love-hate relationship, I always say. Yeah. So keywords are got relative motion or changing magnetic field, then got cutting of flux, then induced e.m.f, then Lenz's law, then induced current. Okay, any four, you get full marks. Okay, this is the classic question on solenoid. I know a lot of people are not very good at solenoid. Yeah. And then part D, diagram shows a pot and induction cooker. You're required to investigate the characteristics of induction cooker. They just say, this induction cooker, I want the most effective one to cook food more effectively and economically. Okay, the power supply has to be AC, alternating. Without an alternating current power supply, by the way, you learn all this in transformer. Without the alternating current power supply, you are not going to have a changing magnetic field. Also, another thing, the type of electromagnetic coil, you must choose copper. This is where a lot of people got it wrong. A lot of people thought, teacher, a cooker, I thought needs a heating element, so I choose nichrome. Nichrome is for heating element. Heating element is a piece of wire that will become very hot when you turn on the power. Copper shouldn't become hot. Because why, guys? When I say type of electromagnetic coil, I already am trying to tell you this coil, this wire, is not supposed to be hot. It is not a heating element. The job of this coil, this wire, is just to produce very strong magnetic field. So please don't think, teacher, the bottom of the pot here, this coil, will become hot. So the pot will become hot. Then the food can cook. No, induction cooker doesn't work like that. Induction cooker works based on the concept of electromagnetic induction. Let me tell you the story, how it works. First of all, you have a coil. And then this coil, because have very strong current, the current keep changing direction, it will produce a very strong magnetic field at the bottom. When it produces a very strong magnetic field, it will interact with your iron pot. At the bottom of the iron pot, you are going to produce eddy current. Eddy current is very useless in a transformer, but eddy current is useful in an induction cooker because eddy current produces heat. Eddy current at the bottom of the pot. So you look at the whole picture, please understand only the bottom of the pot is hot. Only the base of the pot is hot. Is the coil hot? No. Is the surface of the cooker here hot? It's not supposed to be hot directly. Okay, which is why the material of the base of the pot has to be iron, cannot be clay, because it must be a material that is very good at reacting to the magnetic field so that eddy current can form. Okay, without iron, you can also use steel, by the way. Normally steel or iron. Without steel or iron, you cannot produce that eddy current there. So even if I put my hand on an induction cooker, I turn it on, nothing will happen because my hand is not steel, my hand is not iron. No eddy current will form on my hand. It will not be hot. For induction cooker, guys, I'm not talking about there's another kind of cooker. Another kind of cooker got heating element one. You turn on, then the wire will become very, very hot here, red color. And then you put your pot on top. This one can be any kind of pot. Because it's not induction cooker. It's not electromagnetic induction. It's just I supply heat, the wire heating element become very hot, and then it will heat up the pot, it will heat up the food. We're not talking about this. Okay, and the surface of the cooker, I pick ceramic. So the answer is L, right? I pick ceramic because ceramic don't heat up easily, unlike steel, which is a metal. The surface of the top here, I don't want it to be too hot. It is not supposed to be hot. Who is the thing that's supposed to be hot? Just the bottom of the pot, just the base of the pot. Okay, so my answer would sound something like this. I want alternating current power supply. We always say AC to give you changing magnetic field. Always remember this. Transformer, they will ask you, why you need AC? Why cannot use DC? Because AC can give me changing magnetic field, so that cutting of flux can occur. Okay, another one, I choose ceramic because ceramic has high specific heat capacity. It is a good heat insulator. It's not supposed to be hot or have low rise in temperature. The surface not supposed to be hot. The thing that is supposed to be hot is the base. I think the whole thing, the key is here. If you understand that, it's very easy for me to tell whether you know the concept of induction cooker by looking at how you answer the iron base. Iron base can induce eddy current. Can induce current or e.m.f. also can. The eddy current is the one that will produce heat. Okay. Guys, you know, if they ask me to explain how induction cooker work in 4 marks, I will explain like this. First of all, I have AC. The AC will give me changing magnetic field, 2 marks. And then I will induce eddy current, 3 marks. The eddy current will produce number 4, some heat. 1, 2, 3, 4 marks. That is how induction cooker works. Okay, I must apply AC. I will have changing magnetic field, and then I will induce eddy current at the bottom of the pot, and then I will produce heat at the bottom of the pot. That is how I cook. 4 marks explanation. And then next one is we want copper electromagnetic coil. Copper, because low resistance, low resistivity, produce more current, stronger magnetic field. So therefore L is chosen. Okay, Ken? So quite a good question, this one. If you don't know, really, you will find this question very hard. But if you know how it works, how this induction cooker works, it's quite similar to a transformer where you have a primary coil. The iron pot is like your iron core like that. It's like your iron core like that. You will produce a lot of all this eddy current at the bottom of the pot, which is what makes it hot. One common question I get asked, teacher, can I say iron pot is, I choose iron because iron is good heat conductor? No, not the best answer. It doesn't matter whether you are a conductor or not. What matters is, for an induction cooker to work, you must use a pot made of iron or steel because they react to the magnetic field the best. You can choose other metals, but other metals normally they don't form eddy current as well as the iron or as well as the steel. Okay, so I'm not talking about it needs to be good heat conductor and no, that's not the whole point of choosing iron or steel. The whole point of choosing it is because eddy current can form. Okay, can. So that's number 9. Number 10. Okay, number 10. Diagram shows an electric circuit. State the function of a voltmeter. You can just say to measure voltage, measure potential difference. also can. To measure e.m.f. also can. e.m.f. Or you want to write full name, electromotive force also can. Anyone. Okay. Then part B, what happened to the ammeter reading and the voltmeter reading when the switch is turned on? Okay. Right now, when you put your voltmeter there, do you know that when the switch is open, you never connect the switch? Do you know that your voltmeter is going to give you a e.m.f. reading? And then your ammeter reading will be 0 ampere at first when the switch is not connected. Okay, so e.m.f. reading is kind of like, maybe I give you a value to imagine. It's the value that you get when you buy a new battery. When I buy a new battery, maybe the battery tell me the value is 1.5 volts. That's the e.m.f. Okay, so voltmeter is measuring the two ends of your battery. That's why it's going to give you this reading. But the moment you connect the switch, the ammeter is going to give you a reading. Got current now. The moment there is current, now the voltmeter is also going to give you a value that is called potential difference. The value will drop. It would be maybe like 1.2 volts. Again, all these values are just example, just to help you to imagine. Now you might be thinking, then teacher, where the voltage go? Because when there is current flowing, some of the voltage will be stolen by the battery, by the dry cell. Okay, we say there is going to be some voltage drop in dry cell, and the voltage drop is exactly 0.3 volts. The battery took away 0.3 volts, so the bulb will only have 1.2 volts left. That is the value that your voltmeter will give. Okay, so that is the whole idea on e.m.f. chapter 3.3. Okay, so what happened to the reading, ammeter reading? You can say ammeter will show some reading, or ammeter reading will increase, or the needle pointer will deflect. You just tell them that there will be some reading, then can already. Okay, ammeter will show a reading, because just now it was 0. Now it will show some reading, or reading increases also can. Okay, then what happened to voltmeter reading? Voltmeter reading will decrease. Just now it was, for example, the e.m.f. was 1.5 just now. Now you connect, the moment you have current flow, it will not give you e.m.f. anymore. It is not measuring the two ends of the battery only. There is current flow, means the current will flow through the dry cell. And guys, please also know dry cell has resistance. The resistance is called internal resistance. Because in a battery also got resistance, imagine when current flow in, the battery also needs some voltage. How much voltage does it need? It will need 0.3. If the battery needs 0.3, do you agree? The rest of the circuit will only have 1.2 left. Will only have 1.2 left. That is the idea. Okay, so to explain your answer, why ammeter got reading? Oh, because current will flow now. Okay, why voltmeter reading will decrease? Because battery has internal resistance, or because there is voltage drop. In the dry cell. Okay, or you can go and talk about the internal resistance of the dry cell. Why voltmeter reading will decrease? To overcome voltage drop. Sorry, same thing. To overcome, maybe I say internal resistance, my bad. Of dry cell. Okay, can. And then part C, they say the diagram shows 4 types of electric circuit, PQRS. The electric circuit consists of 4 identical dry cells, 2 types of light sources, which are 3 filament bulbs or 3 LED, light emitting diodes. The e.m.f for each dry cell and the power rating for each light source are the same. So you got different light source, different arrangement of bulbs. They ask, study and determine the most suitable electric circuit to produce brighter light and not easily flammable light source. Okay. If we look at the picture, there's answer at the side, right? But don't look at the answer. Let's see why will we eventually choose circuit R. First of all, please make sure you know that we always will choose LED over filament bulbs because LED is very, very energy saving. Maybe you don't know this, but give you an example. Huh? Let's say I need for a filament bulb, I need to supply 60 watts of power for it to light up with a certain brightness. But for LED, the same brightness that I want to achieve, I only need, for example, 8 watts. I need so little power, so little energy, I can get the same brightness for LED. So we always will choose LED. Okay, this one is something you all need to know. Next thing, the resistivity of wire has to be low. Because all this wire, I don't want the resistance high. I want current to flow as smoothly as possible. So I cannot choose high resistivity wire. Okay. So it looks like R is the best answer already. Then the arrangement of light bulbs. We definitely will choose a parallel arrangement over a series arrangement of light bulbs because if one bulb spoil, the rest can still work. And also I will get the same voltage for all the 3 bulbs because in parallel voltage will be the same. Finally, a lot of people thought that type 1 connection of dry cell is parallel. No, guys, this is not parallel, this is series. Parallel means you connect everything with one wire. Don't see because it looks like an S like that. It looks like parallel like that, then it's parallel. No. As long as it's connected in one wire, then we call it series. Okay, so type 1 is series. Type 2 is what we want. Type 2 is a mixture of series and parallel. Okay, a mixture of series. This 2 is in series, but then these 2, they are in parallel like that. Okay, so eventually we say R is the best answer. Okay, let's take a look. So I want LED. Best reason, because low energy loss, low power loss, less heat produced, high efficiency. Okay, you can say very energy saving. We like to say that also. Save a lot of energy, low energy use. Okay, then I want parallel arrangement of light source, or you can say of light bulbs. They accept if you go and draw the drawing out also. Like you tell them you don't want this series one, you can go and draw the arrangement of your light bulbs. If one bulb blows, the others can still function. We like to say this. Okay. If you have many parallel bulbs, the resistance will be smaller. Effective means the total resistance. Because if it's parallel, your bulbs look like this. And when you add up the resistance, you have to add one bulb. Okay, sorry, let me write here. One bulb plus another bulb plus another bulb like that. Do you know that the more branches you add another one, the more you add, because of the 1 over 1 over 1 over 1 over like this, more parallel bulbs means lower resistance. More parallel bulbs means lower resistance. Versus, if you do everything in series, then the resistance will be very high. Yeah, resistance will be very high because how do you add it up? You plus like this. Okay. So that also works. I want a low resistivity wire because low resistance. Okay, more current can flow, less energy loss, less heat loss. Just now I said type 2 connection is what we want, but the mark scheme will also accept if you write type 1. Okay, however, you need to be smart because end up you have to choose circuit R. Circuit R is the best. Okay, so anyways, if I choose type 2, this is what I can say. Type 2 can reduce effective internal resistance. The resistance of the battery will be less. Because remember just now we say, if it's parallel, less resistance. This are all series. Then more current can flow and all. Okay, more power, more energy. Type 1 connection, the other one, is good because you can get high voltage or high e.m.f. If you put a battery in, got 4 battery. If you put a battery in series like this, every battery, let's say, is 1 volt, 1 volt, 1 volt, 1 volt. The total e.m.f. will be very high. It will be 4 volts. Because in a series circuit, the voltage will share, or you plus all the voltage together. But for type 2, right, let's say if you have, I just keep it simple. If you have parallel circuit like this, if here 1 volt, here 1 volt, what is the total e.m.f? It's still 1 volt. Because for parallel circuit, voltage is the same one. Here, same, here also the same. Series circuit voltage will all add up together. So that is the difference. So both also has their advantages lah. Okay, both also has their advantages. So you pick the best of everything. You're considering all the 4 characteristics. End up we choose R. Okay, end up we choose R. Got LED bulb, parallel arrangement of light bulb, low resistivity of wire, type 2 connection. Okay, and then part D. Diagram 3 shows circuit containing 2 dry cell and a mini fan. The internal resistance of the dry cell is 0.5 ohms. The resistance of the mini fan is 60 ohms. Okay. Calculate the effective internal resistance of the dry cell. Effective means total. If it's parallel, you just add up all the resistance like this using the parallel formula. You get 4. Okay, then the answer you need to terbalik. R will become 1 over 4, which is 0.25. Don't leave it in fraction. Please leave it in decimal, please. And then part 2, the reading of ammeter. Okay, reading of ammeter, that means go and find the current. Right now I know my total resistance, my internal resistance is this. My resistance of mini fan big R is this. I want to find I. You go and look at the formula sheet. There's only one formula that has small letter R. Let's take a look. Okay. Wait, it's loading. A bit laggy, this one. Okay. This one. There's only one formula in the whole electricity that has small letter R. e.m.f equals to V plus IR. Let's use that. I want to find I. I got small letter R. I got the e.m.f. Oh yeah, by the way, the e.m.f. If here is 9 volts, here is 9 volt, the total e.m.f is not 18 volts. The total e.m.f is just 9 volts. Why? Because it is parallel. Remember just now I said? Parallel voltage, all the same one. 9 volt, and up here also you get 9 volt. Okay, this kind of arrangement very useful for the batteries to last longer. You keep on supplying 9 volts only, but every battery got 9 volt. It will last very long, this kind of arrangement. Okay, so total e.m.f is just 9. We do not have the V, but don't worry because V is equals to IR. Okay, maybe I rewrite first. Some people will write like this. Some people will also say you can write it like this. Up to you. Up to you. It is the same. e.m.f is 9. Current I want to find. Big R is 60. Small r is 0.25. 60I plus 0.25I, you get 60.25I. 9 divided by 60.25, you get the current. Answer is 0.149 ampere. Okay. That is minimum 3 decimal also. Okay, that is question number 10. Okay, one more, question number 11, compulsory section. This one is on heat. Okay, let's take a look. The diagram shows the initial temperature of liquid X before being heated by an identical immersion heater. Okay, we got two pictures. Liquid X. And then diagram 11.2 shows final temperature after being heated. Okay, so at first the temperatures you can see they are the same. And then after that, the temperatures will be a bit different. One here, after 10 minutes of heating. I can kind of tell already looking at this question, I know what they want to test. You imagine you have a big pot of soup, a very big pot of soup, and you have a very small pot of soup. If I heat with the same amount of heat, 10 minutes later, the small pot of soup, because it's smaller pot, of course, will become much hotter. The big pot of soup will not be as hot because you need to heat up a lot of the liquid, right? And in part A, they ask, what is the meaning of temperature? Just 3 words. The degree of hotness. You want to say the degree of hotness of an object. Can also. Okay. It means how hot something is. How hot something is. Okay. Then in diagram part B1, in diagram 11.1a and 11.1b, compare the initial temperatures and the mass of the liquids before being heated. Initial temperatures are the same, but the mass of diagram A is bigger than diagram B. Okay, so I'm gonna, this one essay you must copy, you know. This is what I mentioned just now. Whatever they ask you to compare, you must copy out. The initial temperature of liquid X in diagram 11.1a equals to diagram 11.1b. The mass of liquid, all this you must copy out in exam. In diagram 11.1a is, diagram A is more than, okay. Okay, the mass of liquid is more than B. Same temperature, mass of A more than B. And then compare the rise in temperature after heating. This one, more rise in temperature, more increase in temperature. Yeah, diagram A is less. Yeah, diagram A is less. So I say the rise in temperature of liquid X after heating in diagram 11.1a is less than 11.1b. Okay, if you don't want to write the symbols, you just write in words, is equals to, is greater than, is smaller than. Okay, then they ask, relate the mass and the rise in temperature. It looks like when the mass is greater, the rise in temperature is smaller. Can I say? The greater the mass, the smaller the rise in temperature. Okay, or it can be the other way around. Okay. And also you don't always have to write diagram A first. You can also write diagram B first. Oh yeah, I noticed a mistake. This is supposed to be diagram 11.2. A, diagram 11.2b. This is after heating. Okay, in the second point. In the third point, sorry. Okay, last one. State the physical quantity that must be kept constant to deduce the relationship between mass and rise in temperature. Actually, they're asking you, if you want to find the relationship between mass and change in temperature, what must you make sure that are the same one? You must make sure the specific heat capacity never change and the amount of heat supplied is the same. Physical quantity kept constant is the specific heat capacity Done. Or another answer is you can say the heat, or you can say the heat come from where? The heat come from the electrical power times time. So you can also say physical quantity that is kept constant is the power and time. Anyone. Okay, anyone also correct. Okay, then part C. Using correct physics concept, explain the above statement. They say, the heat from the sun heats up the land on the beach and the seawater in the same period, same amount of time. It is found that the sand heats up faster than seawater. Explain. 4 marks. A lot of people cannot get it, this one, because they thought this is asking about land breeze and sea breeze, which is not. It is not asking about land breeze and sea breeze. It is just saying the sun is heating the land and the sea. Why one will be hotter faster? The keyword here is in the word faster, which means it takes a shorter time. Therefore, it has a smaller C value. That's what fast means. This is for the sand. I always tell my students, smaller C, smaller T, take shorter time. Bigger C, bigger T, take longer time at heating up. And the first point you must talk about is, of course, their specific heat capacity. Okay, this is the mark that most students got correct. Most students only got 1 mark. Compulsory sectional, most students only got 1 mark. They got this one correct. Specific heat capacity of sand is lower than seawater. Okay, 1 mark. But then the rest, they don't really know how to say, or they answer the wrong thing. The question is trying to ask you, do you know that according to this formula, you are trying to see the relationship of, because their C are different, therefore the temperature change will be different. So please establish the relationship of C and theta. When the C value is down here, you see the theta is on top here. You get a inversely proportional relationship. One up, one down. Okay, 1 up, 1 down. So, okay, specific heat capacity of sand is lower. But other than that, heat is the same, or the heat supply is the same for the sand and for the seawater. Maybe I add one more word, heat supply. The Q never change. The Q is the same. According to Q equals to MC theta, you write this formula, you get 1 mark. When Q is the same, and maybe you can go and mention also the mass is the same, when I got a small c, I will get a bigger theta. It means that the rise in temperature is inversely proportional. How much my temperature change, the theta, is inversely proportional to the specific heat capacity. You tell them that according to the formula, I know this relationship between C and theta. So earlier on, when you talk about the specific heat capacity, that is the reason why at the end, the rise of temperature for, because the sand has a lower C value, and end up the sand will have a bigger rise in temperature. Okay, so I say at last, the rise in temperature of sand is higher than seawater. That's why the sand heats up faster. Keywords, specific heat capacity. Heat is the same. Q equals to MC theta. Talk about their relationship. And then say, rise in temperature is higher. Okay, you can go and add one more point, that is, you can go and say the mass is the same. The heat is the same, and assuming it is the same mass or the same mass of sand and the seawater, one will be hotter, one will be not so hot. Okay, and then part D, I think this next question is quite easy to score 10 marks. The diagram shows a house with green building concept. A green building is a building that gives a positive impact on climate and natural environment. Using appropriate physics concept suggests materials to increase ventilation and ensure temperature in the house is not too high. Your proposal must include the specific heat capacity of material, the type of material used as the walls and the roof, number of windows, and the design of the house. Okay, at first glance, it looks like, oh, this is quite confusing, a bit hard, but really you have a lot of things to say. Talk about the wall, the roof, the number of windows, the design of the house. Okay, let's take a look. I first of all want high specific heat capacity of wall. And also I write high specific heat capacity of roof. Guys, you get separate marks for this. The reason is all the same, because a high specific heat capacity means take long time, very slow at heating up, which is good. I don't want it to be too hot. And it is an insulator. There you go. Good heat insulator. Heat up slowly. Low rise in temperature. Okay. Then you can also go and say what kind of material. For wall, you can say a lot of things. Like you think normally your house wall is what? Concrete, no? Cement, no? Bricks, wood. Wood also good heat insulator. Clay, or you don't know what to say, you just say insulated material. Why? Because all of them high specific heat capacity, less heat will go to the wall and go into the house, less heat conduction, less heat absorb. Roof also the same. Ceramic, styrofoam, asbestos, brick, concrete, polymer. Both you say bricks also correct. Both you say concrete also accepted. I have many layer for the roof so that it's not too hot. Or you just say insulated. Reason same. Less heat flow, less heat conduction, less heat absorb. Windows, more window, many window, large window, you get separate marks. Heat is not trapped. Got a lot of window, the air can move in and out. You can increase convection. Convection meaning airflow, air movement. Okay. Hot air is released to the surrounding. The reasons are the same. And then design of the house wise, I can talk about, maybe I put some air holes on top of the house. So you know your house maybe like this. The air hose we install always at the top here, because hot air will always rise up and then it will escape through the holes. Heat is not trapped. More air flow in and out of the house, better convection, increased air release to the surrounding. I want a higher ceiling, higher roof. Higher so that hot air can rise up. It won't be so hot. Cold air stays in the house. Heat is not trapped. I want a layered window or heat-proof window. So less heat absorbed into the house, less heat conduction, not so hot. Okay? A lot of things to say. You just talk about the wall and the roof, right? You can already get 8 marks, you know, actually. Because they asked to talk about specific capacity, and then they say type of material also. And then number of windows also, you talk about this too. You can get a lot of marks already. So that's why I say it's not difficult to get full marks, this one. Because they accept so many answers. But you must mention wall and roof. Specific capacity of wall and roof, separate marks. Okay, that is the end of SPM 2022 paper 2. Okay, all the best in your exams. We stop here first.